Hi physics, here we are. We're doing part 2 of this problem. We're going to do C and D. This is the space heater problem, so this was chapter 5, homework number 4, I believe. Yeah, I'm sorry. Chapter 9, homework number 5, problem number 4. That's the problem we're doing. And in part 1 of this, we already figured out how much work we're going to do, how much energy we're going to use. We got 43,200,000 joules. And then part B, we figured out how much this will cost. So now we're going to try to figure out part C and D, which is how long could this amount of energy power two different things. First, a 60 watt light bulb, and second, a 10 watt LED light bulb. You know, the more modern, more efficient kind. So what we're going to start with is we already know the amount of energy that we're using. So the amount of energy that we're using, the work that's being done is 43,200,000 joules. So in part C, let's see, we're trying to figure out how long could this power a 60 watt light bulb. I would start with this idea. Go down to the footer, write the equation you're going to use. Power is equal to work over time. The thing we're trying to solve for now is time. So this is going to give us time is equal to work over power. Our work is 43,200,000 joules. Remember that a joule, actually I'll leave it like that. I'm sorry, getting ahead of myself. It's that many joules. And the power we're interested in is a 60 watt light bulb. Remember W in this situation, this is now the units of power. This is not W for work, this is W for watts. I know it's annoying. Blame James Watt for this, for having that last name. So what do we need to do here? First we need to convert this into seconds. And possibly the easiest way to do that is I'm going to go back, I'm going to replace that watts with a joule per second. So this is kind of a field goal post problem, but maybe not even really. So on the top, our units were joules, and on the bottom, we had units of joules per second. So the joules is going to go away. If we do all this, we're going to get an answer in units of seconds. So if you ask your calculator, what is 43,200,000 divided by 60? It's going to give you 720,000 seconds. Sorry, that was annoying me. So there's our answer in seconds. Which is cool. That's one of the things we were looking for. Unfortunately, I asked you for the answer in seconds, minutes, hours, and days. So we're going to need, this is basically just field goal post practice here, because I don't have a good intuitive feel for how long is 720,000 seconds. So what we're doing is we're going to start with this. Time is equal to 720,000 seconds. And then I want to use field goal post to convert this into more reasonable things. So I want to get out of seconds into minutes. So I have seconds on the top. That means I'm putting seconds on the bottom, minutes on the top. I know that 60 seconds is 1 minute. Again, when you're doing the field goal posts, you need the thing on the top to be equal to the thing on the bottom, just in different units. So by doing this, seconds will go away, and I will have an answer in minutes. 720,000 times 1 divided by 60 is going to give me 12,000 minutes. Which is great, but again, I don't have a very intuitive feel for how long 12,000 minutes is. So from here, I'm going to put more field goal posts up. This time getting me out of minutes and into hours. So I have the thing in units of minutes. That means I want minutes on the bottom and hours on the top. I know that 60 minutes and 1 hour are the same thing. So if I do this, this is going to give me 200 hours. because 12,000 times 1 divided by 60 is 200 hours. So time is equal to 200 hours. I'm starting to get a sense of what this means. 200 hours, I can kind of get a feel for what that is, but let's turn this into days to be a little bit more normal about this. So I need one more set of field goal posts, one that gets me out of hours, so I need hours on the bottom, and into days on the top. So one thing I know is that 24 hours is the same thing as 1 day. So doing this would get us out of hours and put us in units of days. So 200 times 1 divided by 24, 8.33 days. So that was my last answer. I guess actually these are all of my answers for Part C, all these guys. So yeah, just quick, let's reflect on that. So we left a space heater on for 8 hours. So overnight, 1/3 of a day. Space heaters use a lot of energy. So the same amount of energy that powered that space heater for 8 hours, 1/3 of a day, it would power a regular old light bulb for 8.33 days. So yeah, a regular light bulb, not super efficient for its, for doing its job, but still uses way less energy than a space heater does. So now we've got one more part of this to do. Part D. We've got to figure out how long could this amount of energy power a 10-watt light bulb. So really the same thing. We're doing this just for practice. We know, again, that the amount of work that we did was 43,200,000 joules. And we know that power is work over time, and therefore time is work over power, which means 43,200,000 joules divided by our 10-watt light bulb. So 10W. But again, remember, a watt is really the same thing as a joule per second. So let's follow the units. I had joules on top divided by joules per second on the bottom. The per second on the bottom, when I do all this, is going to end up being seconds on the top. So 43.2 million divided by 10 is going to end up giving me 4,320,000 seconds. So that's part of my answer here for Part D. Now I'm going to use field goal posts again to change this into the other units I want it in. So time is 4,320,000 seconds. I want to get out of seconds and into minutes. So I had seconds on the top. That means my field goal post needs seconds on the bottom and minutes on the top. 60 seconds is the same thing as 1 minute. Seconds go away. So 4.32 million times 1 divided by 60. This is going to give me 72,000 minutes, which is one of the things I want to know. Now I want to turn minutes into hours. So I need more field goal posts. I had minutes on the top. That means I want minutes on the bottom. And I want hours on the top. I know that 60 minutes is the same thing as 1 hour. So 72,000 minutes times 1 hour divided by 60 minutes. Again, minutes is going to go away. This is going to give me 1,200 hours. And then the last thing I'm doing is that time in hours, 1,200 hours. I want to get out of hours and into day. So that's going to give me hours on the bottom, days on the top. I know that 24 hours and 1 day are the same thing. Excuse me. So hours cancel, and this will give me an answer in days. So 1,200 hours times 1 divided by 24 is going to give me 50. So 50 days. Yeah, so these LED bulbs are great. The same amount of energy, that 43,200,000 joules, that costs $1.32 to use. That would power your space heater for 8 hours. It would also power a regular old-fashioned light bulb for 8 1/3 days. But the reason we like LEDs, they last way longer. They're super, super efficient. Basically the same amount of power, the same amount of energy that would power a light bulb, an old-fashioned one, for 8.33 days. If you replace that with an LED bulb, that amount of power would power this new bulb. That amount of energy would power this new bulb for 50 days. So hopefully that's helpful.